Hello folks, this is Tom from anti-proton.com, and of course, I took my little business trip, and well, I had to come back from the business trip, so I learned a little bit from the first shot and decided to look and see if I could get some more data and figure out some stuff in the second one, and also get the little whiskey ad right there. They didn't have any scotch. I really was very annoyed by that. A proper airplane flight should have a good scotch, like a Glenfiddich Solera Reserve single malt, but regardless, this Jack Daniels was... well, it sufficed. Regardless, I remember I explained in the previous video the Deadzone. Well, in just a second, I'm going to explain the gamma Deadzone. That's what I'm calling it, which really seems to be more detector dependent than anything else. But I can safely say I had a lot of fun, and when I got back, there was a really interesting package waiting for me, which I think the next few videos are going to be talking about. So anyway, enough showing you pictures. Here's what I found. Hello folks, this is Tom from anti-proton.com, and about a week ago I did a video where I took my gamma spectrometer, my Polymaster 1703 MONB, up to about 33,000 feet, and I took a gamma spectrum, and I had some really weird results, and a lot of people contacted me and said, and I'm going to explain the airplane picture here in a second, they asked me bunches of different questions. One interesting question I got from several people, so I figured I would address it, is why is it that I seem to have this zone from around maybe 6,000 or 7,000 feet to maybe 10,000, 11,000 feet, where there was almost no background detected in the Polymaster. I mean, it was when I took a Geiger counter up there, I got the background. It didn't seem to change whatsoever. The Geiger counter just kind of went up as I went up and down as I went down. But the Polymaster had this zone, this strange zone where it seemed to be nothing. And it took me a while to figure it out, and I finally think I have a hypothesis. Now, this is a hypothesis. It is not, confirmed scientifically. We know a couple things for sure that have been confirmed scientifically, that cosmic radiation accounts for most of what's hitting us from space. We know it's very high in energy, and we know that there's naturally occurring radioactive material on the ground. So I kind of combined these together and came up with a working hypothesis, and I think I've reasonably tested it. So here's my airplane to give you an idea. This is the fuselage of the airplane. Here are the wings. Here are the engines. These are high bypass turbofans, in case you're curious. Specifically, this is supposed to be a cross-section of an Airbus 320. Underneath here would be the cargo and support stuff in the top. And here are little stupid seats, and I was stuck on like one of these seats. Okay, so here's the airplane. Now, let's move to picture 2. Okay, how about that? That worked. The key didn't work. See this red line? This is a high-energy particle from space hitting me. Now, this particle could have anywhere from a few hundred kiloelectron volts up to many, many millions of electron volts. And on average, they usually have pretty high energies, 10, 20 million electron volts sometimes. So they're very powerful, much more powerful than the stuff I usually bump into here on the ground. Now, normally, these things will pass right through my detector, because my detector is a tiny little detector. It would be 1 cubic centimeter, except that it's 4 centimeters long, so it's 4 cubic centimeters, if you like, of detector, and it's cesium iodide thallium dope. So it's a nice detector, but a lot of higher energy stuff, things over 1 million electron volts, go right through it often. It has very low efficiency for that. So when these high energy particles hit the plane's fuselage, the metal is much better at stopping them than my detector is. So going to picture 2. These rays are coming down, and some of them strike the airplane, my very body, the toilet, other random parts in the airplane, and they go flying off at an angle. And this change in angle is a change in momentum, right? Remember, momentum is mass times velocity. Velocity is a vector. It has a direction. So the point is when these particles change direction, they lose their momentum. That extra energy has to go somewhere, because energy is never destroyed or created. It's only changed and so on. You remember E equals mc squared. So you end up with a photon flying off at some random old direction. It's not really actually particularly random, but whatever. And I think that these photons are a lot of what I'm picking up from the higher energy stuff, because the muons and protons and stuff at higher altitudes are just... they go right through my detector. It's really only set up for gammas. So I think this is accounting for a lot of my space stuff, but this isn't getting to the point of why it is I've got the dead zone, okay? We know why it looks like it does in the ground. We know why it looks like it does higher up, we think, but we don't know where the dead zone comes from. So let's move to the next one. Okay, here's norm coming from the ground. Norm stands for naturally occurring radioactive material. We have thorium, here's some little rays. We have potassium, here's some little rays. I just drew some crappy rays. Okay, I'm not a good artist. Here's uranium, and you see that flying through the cockpit. So I'm obviously getting bombarded from the ground, and I'll show you proof of this in just a minute. Okay, so we're getting there. Here's what I think. Sea level, 5,000, 10, 15, 20, 25, 30,000 feet. This is my hypothesis. We see these little tiny lines shooting off in the ground. These are naturally occurring radioactive material on the ground. Their photons may or may not make it all the way up to high altitude. A lot of them aren't going to make it. They're going to be attenuated by the air. But even the ones that do, though, are massively diminished in their intensity because of the distance inverse square rule. See the airplane, you notice how the same number of rays are being emitted, but as the airplane's closer to the ground, it catches more of them. This only caught one ray, this caught two, this caught all four. That's really kind of a really crappy way of drawing it. So if anybody knows about 4 pi r squared geometry, then you understand the idea. Basically, the closer you get to something, the brighter it gets, right? Kind of makes sense. And so this right here pretty much accounts for why, I know this is really, really sadly drawn, isn't it? This kind of gives you an idea why going up away from the ground would make the naturally occurring radioactive material on the ground diminish drastically from my detector. It would just kind of disappear from the detector. And when I was popping Spectra, I didn't notice anything above 10,000 feet that looked like norm at all. I couldn't check below there because I'm not allowed to run my spectrometer in spectroscopic mode with all the other equipment while the airplane's flying. You know, they tend to get mad about that. Let's look at space. Space works the same way. The particles are flying down from space and they're getting caught up in the air. They're attenuating, basically changing their momentum and becoming other things. And they make little cosmic showers. But the point is, as you go lower, they diminish. And NASA and all of them know about this because when you get spaceships going around the Earth, they have tremendously high radiation doses and such. So the same basic idea is going down below. So if you take higher intensity here that diminishes as it goes towards the middle, and you take low intensity, it diminishes as it goes towards the middle, I suppose that you end up like this, an area right here where you're not picking up as much. Now, the problem with this is to actually know that this is true, you need some more sophisticated detector equipment and a lot of other things. This is why I call this a hypothesis. And I think it is valid to be a hypothesis. There's some supposition in it, but only some. Let's see here. We'll go back to the beginning again. If this is true, then I should be able to take a spectra at sea level, and I should get mostly naturally occurring radioactive material. So let me show you. Here's the spectra I took at sea level, and if you look, you'll notice in energy here that right here is a peak. See this peak? 1451 should be 1461. Let me move over a little. Right around there's the calibration's a little off. That's potassium. And this guy over here at 603 should actually be 609. There it is, 610, 609. That's bismuth 214. These two guys are usually very pronounced. And in fact, a lot of these little peaks you see here come from uranium, and they come from thorium, and they come from potassium. This is the kind of thing you see when you take a background on the ground. And it's exactly what you should see. So this is what we expect in the ground. So what do we see when we get up to higher altitude? Well, let me move this out of the way for a second here and switch to. I have them all up on my desk here. Here we go. Here's what I got when I was in the airplane. Let me switch out of logarithmic view for a minute, and you notice that there's this huge peak here, and I don't know what this is. I just don't know what this is. You notice how it doesn't look like the one on the ground at all. This part was very smooth than the other one, and this part had more defined peaks. You had lots of little peaks, but they were still a little bit more defined. These are just like choppy, like a saw blade. This thing right up here, I have no idea what's causing it, but it's very strange. And it's not. The point is, it's not something you usually find on the ground. Usually, this is around 70 to 80 keV, but here it's a 280, 290, somewhere in there. Very strange. This is the only really pronounced peak I can identify, 511 keV, and that comes from pair production. Basically, if a high-energy particle strikes a detector, it creates a positron and an electron. The electron flies away, but the positron quickly annihilates, producing two 511 keV photons. Here they are. This is the trademark right here of a high-energy particle. So, did you notice in the other one how there was nothing over here? Let me go back to it for a second and show you what I mean by that. Switching back to the other one, because I think that might be the most important thing to show you. Okay. Do you notice how everything trails off to nothing here when you're? Well, I was in logarithmic view. Let me switch back to logarithmic view. Logarithmic view. Do you see how everything kind of trails off to nothing when you're here on ground level? But look what happens when you go up into the high altitude. Look at this in logarithmic view. Here's the 511 that wasn't in the other one. I'll show you that again. But look at this. Look at this huge rise here. We know the efficiency of the detector is going down, 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 lower, 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 and yet we're starting to get a rise here. And that means that there's a rising of interactions in the high energy that's increasing at such a crazy rate as I went up that it was enough to counteract and even start going against the inefficiency of the detector, which drops to very little over here. So I think that pretty much explains it, because otherwise my experimental results wouldn't match up with what's known by science. Now, there's nothing wrong with that, because the whole point of science is to find and learn new things. But what is more likely? That all of science is wrong and I'm right? Or that, not I'm wrong, but that I'm looking at the data wrong and all of science is right? It's much more likely that science is correct and I'm wrong. Wouldn't you agree? Not 100% always the case, but more than likely. And so in this case, it turned out to be the case. Well, I shouldn't say I'm wrong. I didn't actually say anything to begin with, so I can't really be wrong, I guess. But you get what I mean. So what's happening here is that there's a zone in between the ground and the air where there's the norm's not getting to, but the high energy particles from space are tapering off before they get to. So this is what I think is going on in this whole entire shindig. Anyway, and I'll show you some videos here that I took whilst flying.